Assalamualaikum warahmatullahi wabarakatuh. Saya Novi Mardiana, Dekan Fakultas Teknologi Industri Universitas Islam Sultan Agung. Kami ucapkan selamat datang, selamat bergabung di FTI Unisula. Mari kita jadikan FTI sebagai wadah pendidikan yang mampu menghasilkan generasi muda yang akan mengembangkan teknologi dan menjadi pilar bagi generasi khairul ummah. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Mari kita jadikan FTI sebagai wadah pendidikan yang mampu menghasilkan generasi muda yang akan mengembangkan teknologi dan menjadi pilar bagi generasi khairul ummah. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Mari kita jadikan FTI sebagai
Oke, baik. Terima kasih kepada tim multimedia dan Bapak Ibu. Mohon izin untuk mengecek suara apakah cukup jelas. So before we start, I will ask permission. Is my voice clear enough?
Yes, Mbak Indah.
Okay, thank you. And for students, untuk mahasiswa, mohon untuk mengubah ya namanya. Please change your name using the format lim_name. Jadi tolong dirubah menjadi nomor ID, NIM Anda, kemudian _name. Ya, dan saya izin untuk memulai. Hello, Dr. Mimi and Dr. Simsi. Thank you for joining us here. Okay. Bibi bisa kita mulai ya, Bu?
Iya, Mbak Indah.
Oke. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Honorable Dean of Faculty of Industrial Technology, Universitas Islam Sultan Agung, the respectable Deputy Dean for Academics and Partnership Affairs, Deputy Dean for Administrative and Finance Affairs, Secretary of Electrical Engineering Department, Faculty of Industrial Technology, Universitas Islam Sultan Agung, the speaker of the Electrical Engineering Webinar Series today, Dr. Mimi Faishalini binti Ramli and Dr. Simsi from University Tun Hussein Malaysia, beloved students, distinguished guests, ladies and gentlemen. Very good morning and warm welcome to the Electrical Engineering Webinar Series today. So it's our pleasure to be your Master of Ceremony. My name is Indah Setiawati. And on behalf of the committee, we would like to express our greatest appreciation for attending Faculty of Industrial Technology webinar series today as a part of online lecturer exchange program between Universitas Islam Sultan Agung Semarang, Indonesia and University Tun Hussein on Malaysia. So ladies and gentlemen, first of all, let's us extend our sincere gratitude to Allah Subhanahu wa Ta'ala, the Lord of the world, who has been giving us His blessing and mercy so that we can gather here, and then praise and salutation upon our Prophet Muhammad Sallallahu Alaihi Wasallam, the last messenger, the best figure of this universe, who has carried us from the darkness to the lightness. Ladies and gentlemen, webinars today will provide us plenty of opportunities to discuss, to share knowledge and insight, everything within our theme today, Railway Engineering Technology Program and the implementation of final year project during the COVID-19 pandemic. And here among us there are Dr. Mimi Faishalini Binti Ramli, hello doctor, and then Dr. Sim Sihi from University Tun Hussein on Malaysia, so who will share their expertise to us. And ladies and gentlemen, now we would like to proceed this conference or this webinar by singing the national anthem of the Republic Indonesia and Hymne Unisula. Please stand up. And ladies and gentlemen, now we would like to invite Hassan Mahfud to deliver Al-Quran recitation. Please welcome.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
A'udzu billahi minasy syaithanir rajim. Bismillahirrahmanirrahim. وسارعوا إلى مغفرة من ربكم وجنة عرضها السماوات والأرض أعدت للمتقين الذين ينفقون في السراء والضراء والكاظمين الغيظ والعافين عن الناس والله يحب المحسنين والذين إذا فعلوا فاحشة أو ظلموا أنفسهم ذكروا الله فاستغفروا لذنوبهم ومن يغفر الذنوب إلا الله ولم يصروا على ما فعلوا وهم يعلمون أولئك جزاؤهم من ربهم وجنات تجري من تحتها الأنهار خالدين فيها ونعم أجر العاملين صدق الله العظيم. Wassalamualaikum warahmatullahi wabarakatuh.
Warahmatullahi wabarakatuh.
Thank you, Hassan Mahfud. And my dear Al-Quran recitation makes our soul fully charged spiritually, and may Allah bless this fruitful webinar. Amin. Ladies and gentlemen, now we would like to invite Secretary of Electrical Engineering Department, Faculty of Industrial Technology, Mr. Munaf Ismail, STMT, to give welcoming speech. Ladies and gentlemen, please welcome Mr. Munaf Ismail.
Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Would like to thank God, Allah Subhanahu wa Ta'ala, who has given us blessing and mercy, so we can attend on online lecturer exchange or webinar series hosted by Fakultas Teknologi Industri Universitas Islam Sultan Agung, Sumbar. I would like to thank to Master Ceremony for giving me the opportunity to speak here. Then I would like to say thank you and welcome to Dr. Mimi Faisalini binti Ramli and Dr. Sim Siyi from Universitas Tun Hussein on Malaysia. I would like to express my appreciation to our team who generously helped us to make this seminar come true. Dr. Novi Mariana, Dr. Andres Giono, Dr. Agus Adi Nugroho, and our supporting team, we would not have done it without you. The Indonesian government is trying to advance the education system in this country. The Ministry of Education, Culture, Research and Technology makes several new policies, starting from independent campus or Campus Merdeka. This policy is called of advanced campus size, with an assessment of each key performance indicator. One of the point is study program is collaboration with world-class partner and international standard study program. Our activities today are synchronized with this policy. Online lecture exchange is form of collaboration between Electrical Engineering Fakultas Teknologi Industri Unisula and UTXM Malaysia. Today, in this seminar, we would learn Railway Engineering Technology Program and the implementation of final year during the COVID-19 pandemic. Our speaker, Dr. Mimi Faisalini binti Ramli and Dr. Sim Siyi will explain this interesting topic. Furthermore, we hope this program will continue and improve. Our collaboration between Unisula and UTXM Malaysia. That's all for my speech. I apologize for my wrong words. Thank you very much for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mr. Mona, for your speech. And ladies and gentlemen, before we are going to the main agenda of the webinar today, we will have a photo session via Zoom. So please, I ask to all participants, please kindly have your camera on. We will have the picture, we will take the picture as a documentation. Okay, so today we have 83 participants and still counting. There are 3 screens or 4 screens to capture. Okay, we start from the first screen. Everyone, all participants, please kindly have your camera on. 1, 2, 3. Okay. Thank you. The second one. Okay, you will take 1, 2, 3. The third screen. And the last one. Okay. Thank you very much. And then I will remind all participants to fill up the attendance form and then make sure you have already registered for this seminar and then click for certificate to get your certificate for this webinar. Ladies and gentlemen, we would like to warmly invite our speakers today, Dr. Mimi Faisalini binti Ramli and Dr. Sim Siyi from University Tun Hussein on Malaysia. And this session will be chaired by Dr. Agus Adi Nugroho. He's the Deputy Dean for Administrative and Finance Affairs in Faculty of Industrial Technology and also the lecturer in Electrical Engineering Department. And now I will pass the mic to Dr. Agus. Dr. Agus Adi Nugroho, the time is yours.
Okay, thank you, Master of Ceremony, Ms. Indah Setiawati. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.
Alhamdulillahirabbil alamin. Allahumma shalli wa sallim ala sayyidina Muhammad wa ala alihi wa ashabihi ajmain. Amma ba'd. Good morning, ladies and gentlemen. May Allah bless you all. The Honorable Dean of Fakultas Teknologi Industri Universitas Islam Sultan Agung, Dr. Novi Marliana, along with all of her staff. The Honorable Head of Electrical Engineering Department, here represented by Mr. Munaf Ismail, and the Honorable Speaker in this webinar, Dr. Sim Siyi and Dr. Mimi Faishalini binti Ramli from the University Tun Hussein on Malaysia. And all the lecturers, students, my students here, and all the participants who attend this webinar. I would like to say thank you for attending this webinar, and I do hope that you all will enjoy this seminar and also get knowledge and also experience from the expert. Yeah. Today, in this third round of webinar on online lecture exchange, we would like to talk about the Railway Engineering Technology Program and the implementation of final year project during the COVID-19 pandemic. Here will be presented with our special speaker from UTHM Malaysia, Dr. Sim Siyi. Good morning, Dr. Sim Siyi. And also Dr. Mimi Faishalini binti Ramli. Okay. How are you, Dr. Sim Siyi? Can you hear me? And Dr. Mimi?
Yes. Very clear.
Yeah. This is the first time, we can see our face here because before only see you in the picture, yeah.
Yes.
Okay, although the condition is not conducive, for us to meet here, but I do hope that some day we will, maybe you come here to Indonesia, to Semarang, especially to Unisula, to see how beautiful Unisula is, yeah?
Sure.
Okay, thank you. And for the first time, I would like to say thank you for you being here today to share your knowledge. Yeah, this is important for us because maybe we do have a different experience also. Yeah, so I hope that your knowledge and your especially in transportation will add more knowledge for us. Yeah, we hope we are here in a good condition also in Malaysia. Here I am, Agus Adi Nugroho, and I am here charged as a moderator. Maybe for the first time I will read the CV of maybe Dr. Sim Siyi first, because I don't know which one will present it first. Okay, Dr. Sim Siyi first, and then maybe I would ask the multimedia team, would you please share the biodata of Dr. Sim Siyi? Okay, thank you. Dr. Sim Siyi, the professional engineer, Dr. Sim Siyi, is a lecturer in the Jabatan Departemen Jabatan Teknologi Kejuruteraan Elektrik of Fakulti Teknologi Kejuruteraan University Tun Hussein on Malaysia. Her academic and professional qualification is starting from 2009. She passed from Diploma Kejuruteraan Elektrik from University Tun Hussein on Malaysia, and at 2012 she was Sarjana Muda kejuruteraan elektrik ya, also from University Tun Hussein on Malaysia, and at 2016 she passed from Dr. Falsafah kejuruteraan elektrik ya, also from University Tun Hussein on Malaysia. And her research of interest was renewable energy and also for AI control ya. And the professional societies is Autodesk certified professional, and also the Board of Engineer Malaysia, BEM, yeah. Also Malaysia Board of Technologies, MBUT. Okay, here's Dr. Sim Si. Maybe for the title, I haven't got the title yet. Maybe you can explain to us later. You have almost 30 minutes to explain your topic. And now the time is yours. Please welcome Dr. Sim Si. Thank you.
All right. So actually for today event, instead of kita nak explain on the faculty of kita punya railway engineering and juga kita punya final year project implementation during COVID, and me and Dr. Mimi, we are actually want to share another topic which is kita punya railway electrification, which is related to kita punya engineering lah. So kita akan slot in sikit knowledge sharing untuk railway electrification, and then baru kita akan proceed kepada kita punya kita punya sharing session untuk kita punya jabatan untuk railway dan juga kita punya final year project. So untuk railway electrification, saya akan share bersama Dr. Mimi untuk kita punya topik hari ini. Okay. So saya akan mulakan dengan kita punya railway electrification. Sekejap ya. Boleh nampak slide ke?
Yes, very clear.
Alright.
Yeah, very clear. Okay.
So before we go further, so kita akan start dengan satu sesi sharing dulu untuk apa tu kita punya sesi perkenalan dengan topik railway electrification. Okay. Okay. So untuk railway electrification, apa tu railway electrification yang kita tahu? So sebenarnya railway electrification tu kita refinekan dia sebagai a system ataupun yang boleh supply electrical energy kepada kita punya railway locomotive and kita punya multiple units in the locomotive so they can operate without having an onboard prime mover. So we don't have to carry our own steam or the diesel in the prime mover. So untuk kita operate. So that is what we call as the railway electrification. Okay. So before kita nak buat lagi pengenalan dengan electrification, kita kena tahu dulu kita punya characteristic of the electric traction. So usually some of electric punya railway, dia ada dia punya own generating station and transmission. But normally kita akan purchase from the international grid, from the electric utility terus lah. Okay, so we come of the advantage of the electric railways that nowadays dah many kita pakai kan. So untuk electrification kita ada dua jenis, sama ada kita will go through AC ataupun go through DC. Alright, so kalau saya akan explain untuk part DC dan Dr. Mimi akan explainkan untuk part AC lah untuk kita punya topik hari ini. So actually electric railway they offer a lot of advantage, such as dia ada better energy efficient, dia ada lower emission and lower operating cost. Dan juga dia enable juga kita ada regenerative braking daripada kita punya railway electrification lah. So nanti kita akan go through one by one from this. Alright, so the main advantage for the electrification adalah dia adalah higher power to weight ratio. Sebab kalau compare with another, that we have to bring our own diesel or steam on the board. So electrification is mana dia very lightweight compared to others. So kalau dia dah lightweight, so dia punya efficiency akan jadi laju. Alright. So okay, one of the disadvantage dia adalah dia having a high capital cost. Tapi capital cost ni tak sama with kita punya operating cost lah. Capital cost dia tinggi, tapi in terms of operating cost nanti dia akan kurang compare the others. Alright. Tapi another thing is dia lack of flexibility. Sebab kita electric train kan, kita perlukan sama ada kalau kita guna AC, kita kena overhead punya catenary, ataupun kalau kita pakai DC, kita ada third rails. So dan juga sebab frequency between the country is different. So bila kita nak have a long journey travelling across the countries, so this I think kita kena consider lah. This is the lack of flexibility untuk kita punya electric traction. Okay. So bila kita nak buat classification untuk kita punya railway, kita punya electric railway, kita boleh based on three of these three categories. First, kita based on kita punya voltage, the different type of voltage that we can supply to the railway. And then kita based on kita punya current, sama ada kita AC ataupun kita DC. So kalau kita tengok kalau AC, kita tahu kita kena tengok juga dia punya frequency. Alright, and then we go for the contact system. So we have a third rail, fourth rail, or the catenary. Catenary will be the overhead, which is we use for AC. The fourth rail is actually the extension from the third rail. So we have another return path. Okay, so we're going to have a look one by one after this. So many installations since today was first built around 100 years ago. Then we still can, some is still in use. Okay, the railway system is used. So we'll go for the component that related to the electrification. First thing you have to know what is the rolling stock. Actually, rolling stock is referred to the railway vehicles, including both power and unpowered vehicle. That is what we call as a rolling stock. Okay, these are the main components of a rolling stock here. So we have a lot of, we have the body, the guidance, and the propulsion, acceleration system, and so on. And then the thing that we're going to look into today is the power system. So the power system is actually included for the power supply. And then we have our power generation, power conversion, power dissipation, and juga kita punya power storage. Okay, power storage termasuk kita punya regenerative braking lah, how we're going to store our energy storage. Okay, so untuk power supply transition, we can, like I mentioned just now, we can be either in AC or in DC. Okay, so both also can be used in the third rail, but both are common transition in the track. All right, so these are the oldest bit test track in England. Okay, now we will look into the electrification system by the contact system. So the overhead line by the catenary line will be explained by Dr. Mimi after this. And then I'm going to show you on the third rail and also the fourth rail, which is the system, the DC system, DC electrification system. All right, just have a quick view on the overhead and will be further explained by Dr. Mimi. All right, so what is the third rail? So third rail is actually a method of providing the electric power to a railway train by reusing the continuous rigid conductor placed on the rear and the rear track. This is the thing where we call it as a pickup switch. We're going to pick up the current from the third rail. Okay, let us see. Okay, so you can see from the figure, this is our running rail. These are the running rail here. And then we have the third rail is actually over here, where the train pass by is going to pick up the current over the third rail. Okay, and then of course we have the insulator to insulate between the running rail and also the third rail. Okay, and as you can see here, actually third rail come up with a different type. We can be the top contact, bottom, or also the side. Then we're going to see that after this. So the third rail actually does not require the DC, but in practice, all the third rail system will use DC because it can carry 41% more power than the AC system. So what's the main advantage of the third rail compared to the AC will be the compact. Because of the DC is much more compact, because if you are using the AC, you need to have the catenary, and then you need to have the substation, connected to the substation. So DC is actually provide a much more compact way compared to the AC, and then it's more suitable to use in the subway or also in the tunnel. Okay, this is where we apply for our DC. Okay, let's take a look. This is the thing when the rail pass by, then it's going to collect the current. So the thing that we use to tap to the contact to collect the current, we call it as a pickup shoes. Okay, pickup shoes is like that. Okay, let's see. This is the thing. So usually, the most common use will be the first one we use is the top contact. So you have your current rail here, which is your third rail here, and then you have the shoes on the train on top. So the problem come with this one is very explosion to the human, explore to the animals, and also if in the country they will come with the snows and the thing will come out with the ice form on the rail, and a lot of these plantations bring the risk, or we call it as bahaya lah if we use the top contact here. So people come out with the insulated cover, and then we have the same thing which cover on top part of the current rail, but it's still the export to the human, all the things still can be happen, but less risky. Okay, and then we come up with the site. Okay, then we come up with a site. We call it as a slide contact here. So instead of the third rail is facing up, it's actually on the side now. So now the shoes on the train is just going to tap at the side to get the current, to pick up the current. But actually the side contact is not much better than the top contact, but at least is reduce the exposed to the environment issue. Okay, but for the animals or the thing still can be happen here. Okay, the best one is we call it as a bottom. Okay, we call it as a bottom running or bottom contact. So actually the whole rail here, the running rail here, is fully covered by the insulated cover. So it's really reduced all the problem. And also imagine if there is a flooded or the snow, it's not going to touch anything of the third rail. So the safest one is we go for the bottom contact. Okay, now let's take a look how this thing will be happened.
Dr. Sim, I think there's no sound with your clip.
Oh, okay. Okay, tak apa. We just have a quick view on how the things is going to operate, and they actually come with a subtitle at the screen, right? Just a very quick short video. So this is how the third rail is operation, and now we can take a look in how the current collector, we call it the pickup shoes, is going to pick up the current of the rail. Okay. Tak apa. So okay, we teruskan. And then we come with the grounding system. So instead of we have a third rail, before this, kalau kita guna third rail untuk carry current, so for the we know that we are electrical, so we know that the current have to be returned. So usually the current will be returned on the running rail. So actually it's come up with a lot of issue lah. There's a reason why we're using a fourth rail to carry the return current to avoid the current flowing through the original metals. Okay. So these are how the fourth rail will be used, the grounding system. Never mind, we don't have the sound. We just have a quick view on how the system to be operated. So this is the ground contacts that actually happen in the railway. So it's actually to transfer the electricity from the static to the rotary parts in the threads. So these are the carbon ground contact. All right. Okay. Then we go for the fourth rail. So
enhance transparency.
Okay. So the London Underground incline is one of the few networks that we use for the fourth rail here. So we will take a look in the fourth rail. Okay, so the advantage of the fourth rail here will be we don't have the returning current does not flow in the running rail. So you actually reduce the straight current flowing to the iron tunnels. So the example here, we have the London Underground. Also in Malaysia, we have our LRT2, which is the Kelana Jaya line. Okay, with the voltage of 700 volt VDC. Okay, so now let's go through quickly on the other components of the thing. You know what is the track? The track is where we allow the railway to be moved. And then we have our track ballast. So the batu here all is the ballast. Actually, we come with a very important function to avoid the flooded. Also, actually provide a function for the drainage, not only for the water but also for the oil. Okay. And then we have the railway slipper. The slipper is actually the things here. Okay, it's actually to make the thing to be laid, literally to be more rigid, laying on the ballast. And then we have different type of the slipper. We have the concrete, steel, wooden, and so on. Okay, so we have the first major application of the DC electrification back there to the 1816, where the first electric machine of tram traction with voltage of approximately 500 volt DC were built. Okay, so after 1819, the DC electric traction was actually applied to the metro railway with an increasing voltage. We have increased the voltage to 750 and then go for the 1.5 kV and also 3 kV. Okay, this is the voltage available for the DC now. And then the benefit of the DC electrification, the main advantage there is actually is get the supply directly from the primary lines at the main frequency without introducing any unbalance, or we're not content, or because we are not using AC, we not content any power factor issue or distortion, and also without the risk of unwanted flux then on the contact line. Okay, this is the advantages of we using the DC electrification. So actually now the DC electrification is normally applied on the urban, or we call it the suburban area, and regional electric transport network. So if we talk about the DC, then we know that we have literally the power is from a three-phase distribution network, and then at the medium or high voltage, and then rectified to DC. So all these things will be happening in a traction power station, or we call it as a TPSS. Okay, so actually from the TPSS also we need to choose the location of the TPSS. The final location must be close to the distribution station, and it's actually to make sure that it's enough power to supply for the railway. So this is the criteria if we choose for the proper grid. We need to know about the size of the plant and also the continuity of the quality service. The most important is the possibility of the network. So we have to look in the future what is the expansion of the line that we have, and then before we make the selection. Okay, so this is the DC system. So usually for the DC, like I mentioned just now, we are using the 750, 1.5 kV, 3 kV. Okay, so the maximum now is go for the 3 kV, and because if you going for the higher voltage, there will be higher risk where you need to have clearance. The clearance between the station and the railway will be bigger size. So now usually we'll go for the 3 kV, but in Malaysia we only use for the 750 volt. All right, so this is the DC traction power supply system. So you come with a medium voltage switchgear. Of course, you have the rectifiers, and then you have the transformer, and so on. Oh, it's happening in the power supply here. So this is the generating substation with the DC track line, where you actually come from the power supply from the AC side. You have the power supply from the AC side, and then we'll go for the TPSS. In between, we have a transformer to transform the voltage or the voltage. And then from the TPSS, we're going to fit to the rear of the train, and then we have a rectifier in between. So the voltage will be 750, 1.5, or also 3 kV. So there are two types of possible connection. Either we can use as a branch connection, or we can use it as a cascade connection, or nama grammar we call it as a H cascade, H as arrangement. Okay, let's go through quickly with the TPSS. So the conversion of the TPSS, the traction power substation, they compose of different parts, different voltage, and also the power level. So usually the station will be divided in two sections, which is one for the XC section, which is coming from the tapping from the national grid, or another one will be the DC section, where we're going to, for the DC electrification, we have a DC section, so we can transfer to the traction line. So this is actually what happened here. So the upper part here, we have our HVAC, and then the lower part here will be our DC part. So for the AC, we have from the coming from the primary lines, and then we have the three-phase disconnector. Circuit breaker is actually served with the same function to open the circuit when there is fault. But the difference here is the disconnector cannot be opened when there is a load. Okay, so actually the two things here is a redundancy for a double safety purpose. So anything that one is filled, we still have another for the safety purpose. And then of course we go for the transformer to step down the voltage, and then we go for the rectifier. So after the rectifier, we still need a filter to smooth out the voltage because we know that from the rectifier, the output voltage is not smooth. So either the RLC filter or RC filter will do, and then the voltage will be sent to the contact line to be tapped for the DC rectification. Okay, now let's look at the input line. So the input line from TPSS is actually in HB or in the medium voltage. And it can be either in the overhead line or the underground cable. So this one will be go through quickly. I will go through quickly and will be further explained with Dr. Nimi later on. Okay, then we have our primary input line, and then we have our grabbers. Actually, the grabber is served with the functions for the water drainage, or also the happen if they, because we have the oil type transformer. So if the oil leakage, we have the grabbers is actually to reduce the risk of the fire on the substation. And then we have our voltage transformer, this connector, the rotary disconnector, and the transformer groups. We have the traction transformer, auxiliary service transformer, and also the second line transformer. So this is our traction transformer. And we have our auxiliary service transformer, second line transformer, and so on. So we know that there are two types of the transformer. They can be installed in TPSS, which is the oil field type and also the dry type. Okay, so in the building, usually we are used for the dry type transformer because it provides better safety with the no fire risk. Okay. Okay, now we will focus on our DC system. So we know that if we want the DC, we need to have a rectification. So there is the use of the diode. So the diode makes the use of the high power converter to be possible with the excellent performance because it provides a very short startup times and it can be operated in the dynamic condition. It's actually, you can see here, it can operate from a -50 to a 50 degree under the operating the conditions. Okay, and also the rectifier actually can be cooled by a natural ventilation. We don't need to purposely have a cooling system for the rectifier. So now let's take a quick revise on the three-phase rectifier. So we have two types. Actually, one is control and one is the uncontrolled. So for no matter which type, we still need a filter, RLC filter or the RC filter dimension to be smoother the output of the voltage. Okay, so this will be the half wave of the half wave rectification. So each phase will be fit into one diode. So when the red phase is coming in, so this one will be forward bias, and we will be conduct for the red phase, and then the other two will be in the reverse bias, which is going to turn off. And the same thing will happen for the yellow phase and also the blue phase. This is after the one cycle, we will get the three-phase conductor or the positive side, and then each of it is separate with a 120 degree. So if we want to get the VDC, it's actually we can get it through the equation 1.17 BRMS. And also if we go for the full phase, it's actually the two set of the half wave. So each phase is tapped to two diodes. So when red phase is going through, the positive will go for one of the diode and negative will go for another diode. And actually resulting in the one cycle, we have 6 passing voltage here, and each of it is different with the 60 degree. Okay, this is a full wave. Just a quick comparison between the half wave and the full wave rectification happens here. And then you can see here actually with the full wave, we have a higher voltage and the smoother output. Okay, this is how we're going to get our VDC from the full wave rectification. And we now look at the control rectification. So for the control, it actually is addition another gate. The diode actually turn on just a gate to pulse the thing to make the diode to be turned on. So we have a control rectification and also the uncontrolled. So uncontrolled, when the supply is coming to the uncontrolled rectification, the output will be a fixed value. So if we have a control, we can vary our output voltage. So there are a lot of type of the time resistor with the control diode. So the most famous, I think, will be the GTO, the diode, the triode, and also the silicon control switch. Okay, so what is the thing that happened between the diode and the thyristor in our electrification for the railway? So actually, we know that the thyristor have a lot of advantage. The main one will be that we can actually adjust the voltage by redoing the firing angle. So if we can adjust our voltage, it's actually, we can reduce the line losses because when the voltage, we can be adjust based on the requirement. So actually we can reduce the voltage losses and at the same time we reduce the current. So when the current is reducing, so we can reduce our losses of the line. Okay, another thing, but we have to notice that for the thyristor, it's actually is a very significant absorption for the thyristor for the reactive power. So if we are using the thyristor, we have to know about the power factor correction things. We need to install the power factor equipment. And also actually they will come up with some harmonic contents and also increase the amplitude of the voltage harmonics. But the main thing is that if we are using the diode, it's not possible to have a direct regenerative electric braking. So if we're going for the electric regenerative braking, we need to have a thyristor because we need to have arranging two separate thyristor bridge in anti-parallel. So one is function as a rectifier and another one will be function as an inverter. So this will make the regenerative to be happens. We will see here. Okay, so in the reversible substation, allow the regenerative braking power to be stored to the grid, and there are no other traction load to be contained capable of the observing. So we have, like we mentioned just now, we have one is serve as a rectifier as usual, and then we have another with the thyristor which serve as an inverter here. This is what happened in the substation. Okay, so actually the transport station system are one of the areas where there are many opportunities for the energy conservation that can be happens. So we can conserve a lot of energy and then we can reducing a lot of the operating costs. So so the way that we can save the energy, we need to have the braking energy from the trend, which is the electric regenerative braking here. So you can see from the net traction energy here, the energy flow in the traction system is actually, they are the 10% from the catenary of the railway. So this 10% is going for the infrastructure losses, which actually happens in the substation and the distribution. And then in the rolling stock, the major part will be on the auxiliary load here, which actually contributed by the HVAC system, our heat ventilation and air conditioning system. And then we have 40% of the traction loss. This is because of the power converter and also the motor. But actually now today the motor contribute less because the motor is actually go up to efficiency to 95% in the traction use. And then we have our motion system, which is the aerodynamic opposition of the vehicles, and also maybe the friction that happens between the wheels and the rails. And then you can see here the biggest part is the braking energy. But for this braking energy, only 17% of it is irreversible. So this one, the loss we cannot be covered because due to the friction, power electronic transmission, and also during the dynamic braking or this thing. But big part of it, which is around 25 to 35%, we can recover this braking energy. This is the thing we can be safe and we can reduce the operating cost here. So we know that for the recovering, we actually can convert the kinetic energy to the electricity through the heat. So the electric motor will be work as a generator. So the heat up the energy that will be recovered, the regenerative energy, we will use for the auxiliary supply in the trains itself. Okay, so if there is extra, which actually will be feedback to the overhead contact line, and they can be used for the train at the same time in the same power supply station. If there is not used anything, so the energy will be just dissipated through the resistor bank. So we can take a look here. This is what happened. So when the train here is braking, so the energy will be recovered back here, feedback to the substation. If there is another train coming in acceleration, so they will directly supply to the traction. The carrier. So if the braking for the first train, is actually the energy can be transferred to the second train, which is the accelerating here. If the energy is not in use, will be just dissipated through the resistor on the board. But actually at present, the most of the energy is dissipated through the resistor here, because it's actually a very low possibility that you are in the same place, in the same station. One train is braking, another train is accelerating, because normally in the station, so both trains will be braking at the same time. So that is important here. When the energy is recovered, we need to store in the device. We have energy storage here. So because the braking is just a short time, is not in the continuous time. So the best thing for us to store the energy here, we are using the supercapacitor bank. Okay, let's have a quick view here. So when the braking train is approaching, so we will collect the energy, regenerate the energy, and contact safe in the grid line, and then it will be direct to the supercapacitor system here. Of course, we cannot tap directly from the grid line. We need to have a DC-DC converter here to step down the voltage and so on, and then we will solve in the storage, or we will go for the other use here. Okay, so instead of this is the supercapacitor system. So we go for the grid line, we go for the converter here, and then we'll go for the bank of the supercapacitor to store the energy that we can recover from the braking of the train. And then this is the system of the energy system, whereby if we are using the battery to store of the energy. So we come up with the advantage and disadvantage of the supercapacitor. So the supercapacitor provide a high cycle life, fast charging and discharging this characteristic of the supercapacitor. But we also come with the disadvantage that you have a gradual voltage losses compared to the battery. All right, I think this is from me from a short on the DC electrification, and then Dr. Mimi will be continue with the AC electrification system, a very short sharing from the AC electrification system, and then we'll go for the implementation of our railway faculty in the Department of Railway in our faculty, and also the final year project after this. Okay, Dr. Mimi.
Okay, thank you, Dr. Sim Siyi, for the explanation. There's so many new things, yeah, some that are new things for us, and maybe Dr. Mimi will continue. And maybe before I continue, Dr. Mimi continue the speaking, I would like to read the CV of Dr. Mimi. Okay, thank you. Dr. Mimi Faisyalini binti Ramli, a lecturer in Department Jabatan Teknologi Kejuruteraan Pengangkutan, Fakulti Teknologi Kejuruteraan, University Tun Hussein on Malaysia. And her academic and professional qualification starting from 2004 is Sarjana Muda Kejuruteraan Electric and Electronic at UTM, yeah, University Teknologi Malaysia. And at 2010, Sarjana Kejuruteraan Electric and Electronic and Telecommunication, also from University Teknologi Malaysia. And the last, the doctorate is 2017 from Dr. Falsafah Kejuruteraan Electric and Electronic from University of Manchester. And the research interest of Dr. Mimi is a sensor, imaging, and signal processing. And the professional societies is a Board of Engineers of Malaysia. Thank you. Maybe Dr. Mimi, you have 30 minutes to continue the speak to give us more explanation. The time is yours. Dr. Mimi Faisyalini binti Ramli, please. Thank you.
Okay, Bismillahirrahmanirrahim, and Assalamualaikum, Dr. Agus, and all the delegation.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, first of all, I would like to thank everyone, especially the delegation of Unisula, for inviting us for this session today. Despite of today is Saturday, a weekend, kan? But I can see that there are almost 100 participants in this session. So we are very glad. We thank you very much for this opportunity. We are also actually new in this. I would like to talk about this railway engineering just now, like what has been mentioned just now. Tapi honestly, we are actually also new in this railway engineering education. So I really hope that that this is the first step, and this is what we call every success starts with the first step. So I'm really looking forward that this could be one of our kickstart for a future collaboration. So we really thank Unisula for this opportunity. Okay, so let me share the slide. Okay. Actually, we can do this interactive. Dr. Agus or anyone can just chip in, so we can do this like a discussion. We know that in railway engineering, Indonesia has great companies, has great, you have PT Inka, right? I think Unisula is like only 3 hours. I checked from the Google map, honestly. Yeah, in
Yeah, that's right.
Java, right?
In Madiun, yeah.
In Kepulauan Jawa. Kalau salah,
Jawa.
Dr. Agus or anyone
Yeah,
can correct
that's right.
me.
In Java.
Yeah, and then I think your first rail network was started in Kepulauan Jawa, betul?
Yeah. Yes.
Tapi saya juga tidak pastilah sama ada Unisula ada program education that is related to railway engineering specifically, or not yet?
Not yet.
Not
Maybe
yet. Okay.
after this, yeah, we also interesting in maybe sometimes if we already have, we forget to do that.
Yeah, because it is because railway engineering as a whole is an integrated discipline that whereby we have electrical in there. Sebab itulah hari ini kita ada daripada fakulti daripada electrical fakulti kejuruteraan electrical and technology together in railway is integrated of electrical, electronics, rolling stock, which falls under mechanical, and also civil. Yeah, so yeah, any disciplines can chip in. So I believe that in the future we can always work together. Okay, let me share. Can you see my slide?
Yes, yes.
Yeah. Okay, so this is actually, thank you for the introduction just now. Okay, I don't need to introduce about myself anymore, but actually before I joined the academic in University Tun Hussein on Malaysia, I was an engineer in the manufacturing. My last designation was a senior engineer in Western Digital. So my background is a little bit different. So before that, I had some opportunity working abroad in United States, and then I pursued my PhD in the United Kingdom. So I was basically in electronics. So before that, I used to play around with 5-volt, but now today, as in railway electrification, we are talking about higher voltage, high voltage, medium voltage, okay? So today, I would like to explain a little bit as what Dr. Sim has mentioned is on AC electrification for railway. Okay. Here you can see like what I said. Okay. For today, we are focusing on this, the green one, on the electrification and power supplies. That is one part of the railway as a system. So you can see here, we have control systems, we have communication and signaling system, we have traction, we have ATP, we have structure, and etc. The point is that in railway engineering, electrification cannot stand alone. We need the car, we need the rolling stock, we need all the construction or from the civil part of it. We need also the traffic system, which we call communication and signaling system, that is more on electronics. And we need engineers also for the track work. That is why we have the sleepers, ballast, and etc. The point is that we need all the engineers from every disciplines to work together in this. Okay. All right. Okay. Saya sambung sedikit on the DC tadi, is actually from Dr. Sim Si. The UTHM, our university, our team has a slight experience in doing DC maintenance with our rapid rail. The rapid rail is the operator or the most famous operator that is operating our light rapid transit, which is the LRT. Okay. I believe I know that Indonesia has as well this one. Okay, so just to share with you, these are the activities, night shift activities while doing maintenance with our LRT that involve the staff from the University of Tun Hussein on Malaysia and as well as our operator. Perhaps in the future, kalau Unisula ada such program, Unisula perhaps will be working with PT Inka, that or something like that. That is the point that I'm trying to deliver. So although we are lecturers, sometimes we have to went outside to do some maintenance work, to do some practice on our maintenance work for the railway. This is for electrification for today's lecture. Some maintenance work on the circuit breaker for our LRT. So this is done at night from, I would say we stand by at 11 until 4 o'clock in the morning. So what we did last time, we did some maintenance, cleaning and checking for the circuit breaker, for the switch gear, for the rectifier, for the isolator, and etc. So this is just to give you an idea that what we learned today, although today is just an introduction, is actually very related or very relevant to the real world industry, to the real railway engineering work out there. So kalau ada di sini anak-anak, students yang berminat untuk menceburi bidang railway engineering in the future, some parts of your work, some basic could be something like this. Okay, all right. Okay, so sebentar ya. Okay. Apa tu? Okay. Kalau tak ada apa-apa pertanyaan ya, saya teruskan dengan introduction to AC. Okay, AC and DC. In Malaysia, I'm taking Malaysia condition as a study case. So in Malaysia, we implement two systems to electrify our rail. So one is DC, one is AC. DC, direct current just now, is for the urban railway. In Malaysia, we use 750 VDC, but I think the Indonesia could have different system, yeah, for urban. If you know, I think it's something like 1500 VDC, 1500 VDC or something else. I'm not so sure. Maybe perhaps Dr. Agus lebih tahu daripada saya ya, ataupun yang lain-lain. Okay, DC is for urban, but AC is for mainline. Jauh ya, untuk jarak yang lebih jauh, kita gunakan AC because of some benefits that AC system has. So my part will be explaining a little bit, sikit saja about introduction about the AC system. Kalau di Malaysia, in Malaysia, we use AC system untuk jarak yang jauh daripada selatan ke utara, dari Johor ke Kedah. Ya, dari dan operasinya oleh KTMB, Kereta Api Tanah Melayu Berhad. Okay. Alright. So saya ada sedikit video di sini untuk saya playback, untuk di play, tapi let me check if we could get the sound. Minta maaf ya sebab agak jarang menggunakan Zoom ni.
energy efficient mode of transport.
Boleh saya pastikan, dengar tak sound? Dengar?
Dengar.
For freight as well as people.
Dengar.
Can we watch this first, ladies and gentlemen?
Electric railways are a non-polluting, energy-efficient mode of transport for freight as well as people. Traction power for electric trains can be direct current, alternating current, or even a composite system employing both alternating as well as direct current. Therefore, railway electric traction can be classified into three main types: direct current electrification system, alternating current electrification system, and a composite system. Direct current or DC motors have a high starting torque and moderate speed control. They provide high torque at low speeds and low torque at high speeds. This led to DC series motors being extensively used in the DC traction system. A DC electrification system has several advantages. It allows rapid acceleration and braking of DC electric motors. DC systems cost less compared to AC systems. There is less energy consumption and they take less space and have lower weight. Importantly, a DC system does not cause electrical interference with nearby communication lines. Typically, in DC traction systems, three-phase power received from the power grids is de-escalated to low voltage and converted to direct current by the rectifiers and power electronic converters. DC electric power can be supplied to the locomotives through third and fourth rail systems when operating voltages are between 600 to 1200 volts. For higher voltages of 1500 to 3000 volts, electric supply is provided by the overhead catenaries. However, DC voltage decreases with increasing length and therefore necessitating expensive substations at frequent intervals, typically between 2 to 4 kilometers. The overhead wire or third rail must be relatively large and heavy. Alternating current or AC traction has several advantages which have relegated DC traction to the sidelines. AC power can be easily stepped up or down. It allows easy controlling of AC motors, and the interval between substations is larger, being between 20 to 30 kilometers. Moreover, it can use lighter catenaries and low currents can be transmitted at high voltages. It also has reduced capital costs of electrification. The supply systems of AC electrification include single-phase, three-phase, and composite systems. The single-phase 25 kilovolts at 50 Hz is the most commonly used configuration for AC electrification. It is used for heavy haul systems and mainline services since it doesn't require frequency conversion. This is one of the widely used types of composite systems wherein the supply is converted to direct current to drive DC traction motors. Although systems consisting of 11 to 15 kilovolt supply at 16.7 or 25 Hz are also used by some railway systems. Three-phase AC locomotives employ three-phase induction motors rated at 3.3 kilovolts at 16.7 Hz for traction. 25 kilovolts at 15 Hz supply from the catenaries is converted to electric motor rating by transformers and frequency converters. Nevertheless, AC traction also has some drawbacks such as increased costs of maintenance of lines and the need for increased clearances in tunnels. Energy efficient
Okay, so from the short clip just now, so what we can understand is that there must be some alternative to a system. Like in this subject, we have DC, but DC is not suitable to cater long distance. So we have AC, okay? AC, why we have AC is because of the loss is, we have lesser loss with the AC with the long distance. In the clip, it was mentioned clearly that AC, when we implement AC, first it enables or it allows one substation to have a longer distance between each other. So one TPSS to another, you can go up to 30 to 30 from one to another because you need a consistent supply. Unlike if we implement the DC, then we need the substation to be very close to each other. That will be DC. That is why DC is more suitable for urban railway transportation, which for the LRT. But for the main lines, we take up or we implement the AC system. Okay, because this is the introduction, then we make it simple for you to pick up some of the points first, okay? So, okay. All right. This is what we have in Malaysia. We have 25 kV AC 50 Hertz. Why I'm taking the condition in Malaysia? Because there are many other models or there are many other settings, there are many other systems that are implemented in the world. Today we are talking about 25 kV AC 50 Hertz with overhead catenary system. But if you go further, if you study further, you can find as well other frequency, other voltage, or combination of the power rail and as well as the catenary system. But if I would like to explain all the system to you, this 30 minutes will not be enough. So I'm taking the current, I'm taking the scenario in Malaysia as a study case for a fundamental understanding for the students, yeah? So in Malaysia, we have 25 kV AC 50 Hertz, and the operations that picking up this system is we have this commuter, the ETS run through our West Coast. We have the KTM Northern Sector. We have also KTM Seremban Line. We have also the KLIA Express. I believe that some of you might have some visits before the pandemic to Malaysia. If you have experience taking our KLIA from the airport to our KL Central, that is also using the AC system. Okay, Dr. Agus, maybe kalau di Indonesia ya, sistemnya saya rasa untuk DC is 1500 VDC mungkin, tetapi untuk sistem-sistem lain yang ada mungkin yang lain-lain di future in Kalimantan, kalau jaraknya jauh mungkin dia menggunakan AC, tapi I'm not so sure about that as well lah. Okay. Okay, so in short, just now was written, but this is the map. So for AC in Malaysia, we have this. We have from Johor Bahru to Padang Besar. So the red one is the one that the double track, and the yellow one is the AC double track that is currently in progress of upgrading. And we have also the East Coast Line to Tumpat. So this is just an introduction to our rail in Malaysia. And in our state, in the state of Johor, because our university, the University Tun Hussein on Malaysia, is located in Johor. which is in the southern part. So we have this, yeah. We have from Johor Bahru Central to Gemas. This is also the AC system. And in this map, it shows the stations, okay, the main stations, the new stations, and etc. Okay. And we are also planning for an RTS that is from Singapore to Johor, because we have so many workforce Malaysian working in Singapore. So we believe that if this happen, if this completed, it will be giving a lot of ease for the citizens. Okay, right? Okay, like what I said, it's not only one system. It's not only 25 kV AC. We have many variations in the world. We have, for example, 25 kV AC at 60 Hertz. We have also 20 kV at 50 oxyhertz. We have 12.5 kV. We have 12 kV. We have 6.25. We have 2 times 25 with auto transformer. Okay, so there are many variations, but how we select what system for which, that depends on the requirements, that depends on the design, that depends on the standards that we would like to follow. I think it is worth noting that this system, 2 times 25 kV auto transformer, is normally adopted by the high-speed rail. Yeah, so most of the high-speed rail in the world, they're picking up as well the AC system. Okay, again, I'm taking our southern double track system in Malaysia to introduce this AC. So our track consists of 192 km from Gemas to Johor Bahru, like I've mentioned in the map before. And it is using the overhead catenary system, which I would like to emphasize. So what is the overhead catenary system? In DC just now, Dr. Sim mentioned about the third rail and the fourth rail system, which is associating with the power rail, which is picking up the power from the power rail. We have a running rail, we have power rail for our DC using shoe collector to picking up the power, okay? Either third rail or fourth rail, which is in Malaysia, we use third rail and fourth rail. 750 DC, 375 positive 375, negative 375. But this one, unlike the DC, is using OCS, overhead catenary system, which I classify to 2 main substation. We must have the traction power supply system, and we need to have the OHLE, which is the overhead line equipment. Senang cakap, we have the power, we need the equipment to supply. Okay, don't be normally people will question about traction power and just a normal power supply, HV or MV, high voltage or medium voltage. Traction power, normally we are referring to the power that makes the car move, that makes the car rolling stock, kan? Power that gives power for something to move. So we call that traction power. Okay, all right. So dua penting, TPSS and OHLE. Okay, to make your life simpler, the schematic, an example of schematic diagram for the AC system. Satu is from your national grid. Tap from your national grid. For example, 132 kV. Definitely. Anything, any system, you have to tap from the national grid. from in our case is our Tenaga Nasional Berhad. And then we convert we tap 132 intake from the national grid. We have this feeder station, we convert that to our 25 kV AC step down. Okay. In this feeder station, then we have all the devices, equipments. For example, the transformers. You have to step up, step down. And then we have the circuit breaker, we have the feeder system, we have many things in here. But for today, it is good enough for you to pick up the main idea of this. Tap from the national grid goes to the TPSS, the feeder station that converts the incoming to the traction power, in this case specific, from 132 to 25 kV. And then the third one, we have this catenary system. Okay, in this case, using the OCS, you can see this arm, this part. Okay, this part. Okay, catenary wire. Okay, simple. Next. Okay, this is just what I've mentioned. The traction power mostly consists of feeder station, like what I have mentioned. In the feeder station, we have transformers, isolators, circuit breaker, the bus bar. This one, I believe that all of us, the electrical engineers, we have the basic of it already. Okay, transformers to transform, step up, step down. Okay, we have the isolator to isolate the circuit, and then we have the circuit breaker to break the circuit if anything happens, if overloaded, and etc. And the bus bar, and also we have the protections. Okay, the protections of the system. For AC, for this railway powering system, instead of we have only one feeder station, we have also the midpoint in between the main. So in between feeder station, we have midpoint track sectioning location as a backup in case of supply loss. So bukan satu feeder sahaja, but we have something in between. And also at the end, we have tie circuit breaker. What's the difference between a normal circuit breaker and also this tie circuit breaker? Normally, this tie circuit breaker, we put it at the end of the circuit. So, and then it ties or it connects, ya, sambungkan dua. Satu kita pecahkan dan kita sambungkan. Okay, that is mainly things that is in the traction power supply system. Okay. Next, tadi saya cakap kan, I mentioned about two things, the TPSS and the OCS, Overhead Catenary System Arrangement. So for the overhead catenary system, overhead means di atas ya, power you got from top. Berbanding kalau kita guna tadi, kita guna itu third rail, fourth rail is from the shoe collector, from bottom. This is overhead di atas. So parts ataupun the wires that we need is something like this. Okay, we need the dropper, we need the Z wire, we need the support, we need the bracket, we need the stitch wire, we need the contact wire. Why is this contact wire? Is to contact with the later we will see the pantograph. We call it the pantograph, so that our train can get the power supply. Why is this important? Because we need to know the feeder, the feeding elements, the infrastructure of the feeding. Okay, so this is the pantograph. The pantograph is the arm that is melekat, or we put it on top of our rail. So this is a single arm pantograph. Okay, you can see here the parts of the explanation of the pantograph. We have the palette, we have the metallized carbon strip, we have the upper arm, we have the lower arm, and we have also the lifting device. So it works like the arm it's on top of the rail to connect with the wire, with the contact wire. Okay. It's not only like this. In the world, we have many designs. This is a single arm. We have also the double arm. Double arm. The double arm is like this, double arm. So you can see here on the right side, my right side, you can see the diamond shape or the double arm. For our line in Malaysia, we use a single arm. In Europe, in Switzerland, last time, I think the modern one is a single arm, but the previous one we use a double arm. Okay, right. So this pantograph will connect to the contact wire to get the power. Okay, I have another video to explain the pantograph mechanism. Shall we watch it now? Okay.
The overhead current supply system plays an important role for an electric locomotive.
Can you hear the voice? Okay, right.
The overhead line is called the catenary system, and the power is transmitted down to the motors via a pantograph of the locomotive. In this video, we will learn about the pantograph mechanism. So, the question arises, what is pantograph? A pantograph is a device which is mounted on the roof of an electric locomotive. It unfolds and extends along a vertical axis. Its role is to collect power through an overhead tension wire and send it to the transformer. The main components of a pantograph are base frame. The base frame supports the fixed part of the frame and is mounted on supporting insulators of pantographs. Base frames are usually made of profile steel, plates through extrusion, or steel tubes through splicing or castings, and profile steel through splicing. Lower arm and upper arm. The basic parts of a pantograph is a lower arm that pivots against the roof of a loco and is attached to the upper arm that is in turn attached to a collector head. Main spring with yoke assembly. Balance rod and carbon strip, etc. Carbon strips are proved to be the most suitable material to copper and copper alloy contact wires. Carbon strips have good self-lubrication and arc withstanding and can meet the dynamic need of high-speed pantographs. Compressed air system assembly. There are two types of pantographs, like single arm and double arm pantograph. The most common type of pantograph is the single arm pantograph. When a locomotive is to be started, the pantograph is pushed up with the help of air pressure, which is delivered by a small compressor, delivering air at pressure of 7 kilograms per square centimeter. And some modern pantograph using a piston cylinder. This pressure pushes the pantographs and up till it touches the contact wire. But if there is any disconnection for a short duration, it won't affect the power supply because the capacitor will be there after the rectifier, which will ensure the energy supply all the time.
If you watching this video, don't forget to share your
Okay, jadi itu tadi sedikit sebanyak how the mechanism of the pantograph. I think it is easier to understand whenever one watch a clip or a video to understand that. So the benefits of having these AC tractions, like I've said before, AC tractions are used to meet the train's high power demand. High power is 25 kV, okay, and it's minimized power loss. And for a single phase AC, it enables or it allows some of the fundamental objectives of electric traction to be achieved. For example, to ensure appropriate values and to have a possibility of maintaining a single wire contact lines and direct connections, increase the line surface power density. These are all the characteristics of the AC tractions. And it reduces transmission losses over longer distance. This is, I think I've mentioned it like 3 times. So it allows fewer substations for more powerful locomotives to be used. And normally it's 122 step down to 25 transformers, although we have many other variations in the world, okay? So that's not limited to 25. You can see that like what I've shared before. And 25 and AC is ideal for railways that covers long distances to carry heavy traffic. Yeah. So other examples of AC electrification. In the future, Malaysia actually planned for HSR, but currently we are a little bit unsure of this project. But I believe, and Indonesia has one too, the HSR, I think, planning or under construction. So these are the example of the high-speed rail that is using the AC electrification. For example, the high-speed one. The high-speed one is in the UK. This is a driven line from the Eurostar. The Eurostar that crossed the English Channel from London to Paris. That is a different line, but this is a newer one, the high-speed one. You can check it online. We have also the Thalys using 25 kV AC. The Thalys, I took Thalys from Brussels to Paris, the red one, the high-speed rail that is also using 25 kV AC. The TGV duplex, this is the Paris TGV, if I'm not mistaken, is the French operator. And also the Taiwan high-speed rail, the Trenitalia, the Italian rail, and also the Shinkansen. I specifically wrote there Hokkaido Shinkansen, but if you Google, then you can find many other Shinkansen line as well using 25 kV and etc. Okay, so these are the examples. So in the future, if the students one day an engineer to design this high-speed rail system, you can consider all this characteristic, yeah. But definitely a very detailed requirements, a very detailed engineering specification needs to be defined upfront before we select the most appropriate, the most suitable system for our rail operation.
Now we go to class.
I have students actually working on rail, on this railway electrification, whereby although they are doing specifically on 25 kV AC railway system, but their study must also include For example, the cost saving of the proposed system. For example, their study includes the cost or the calculation of the mass offset. I'm sorry, these terms might not be familiar to you, but their study includes the mass offset that is optimized so that they can do some cost saving in there. So the point is that it's not only about the work could include not only giving power, but also the optimization of the power infrastructure so that we can have an optimized system. At the same time, we can optimize the cost as well, the operation cost, the maintenance cost, and etc. Okay.
Now we go specific to
Right.
so now let's move to the
Sorry, I have this.
so now let's
Okay. I have another example in this. Actually, this is an example of power substation by Siemens AZ Traction, but I don't plan to further explain on this. This is just to introduce to you the Siemens AC Traction example. And also I have a power protection interaction system. This is actually another topic. Any system, especially in this high voltage, medium voltage, we really need this power protection. Why we need? Because we would like to protect the people, okay, from electric shock. And we would like also to protect the system and also the equipment that we use. Because if we don't protect, that is a tendency of hazardous, there is also tendency of fatalities and etc. So every single system we have power protections and to avoid hazards. Okay. The damage to the system could be from thermal damage, electro damage for electric equipment and etc. Okay. Okay. I think I've been taking more than 30 minutes for now, so I would like to conclude my my session. There are mainly AC and DC. There are benefits from both system, AC and DC, but mainly DC is suitable for urban. AC is more suitable for main lines, that is with a longer distance. And there are many systems associated to that. The current collecting system, we have third rail, fourth rail, we have catenary with OHLE, overhead line catenary equipments. So how to adopt, how to select, that depends on the requirements, that depends on the engineering specification that we choose to adopt. And there must be power protections to the systems. So with that, I think I end this AC railway electrification. I pass this session back to Dr. Agus.
Okay, yeah.
Right.
Thank you
very much.
Yeah. Thank you, Dr. Mini. This is knowledge for us, yeah. This is a good, yeah. Although we do have the same electric railway, but because here in Semarang is usually we have only diesel electric for the train, not electrification. We have electrification, but only in a big city like Jakarta and also Palembang. Yeah, I already see that there are electrification for the railway, but in here close to Semarang is that we do have only diesel electric. So This is look like a new, a new for us. Very interesting, and thank you for the explanation. And now we come to the question from the audience. I would like to hear from the student. Maybe you have some question from Dr. Mimi or also Dr. Sim Siyi. You can raise your hand or you can write down on the chat. If you hesitate speaking in English, you can say it in Indonesia or just write down in the chat in Indonesia. Maybe I can help you to explain to Miss Simsi and also Miss Mimi, Dr. Mimi ya. Atau mungkin langsung ya pakai bahasa Indonesia, sepertinya juga paham. It's okay ya.
Yeah, it's okay.
Itu ada yang
It's
tanya di
okay.
chat box, Pak.
Oke,
Bisa,
yang di
bisa.
chat sudah tadi Pak Budi ya. Ini buat cadangan tadi Bu. Oke, while waiting for the other question, this is already one question from Mr. Budi Pramonojati. Yeah, I think this question is for Dr. Sim Siyi, but maybe Dr. Mimi can add more information from this. Yeah. The question is, in the case of storing electrical energy from the braking system, is there another technology that is more efficient in function and price? As far as I know, it's quite expensive if we use battery. Maybe Dr. Sim Siyi or Dr. Mimi can explain this.
Okay. So as I further explained just now, actually the battery is not the only option that we have. So actually, the original one, we actually start with the flywheel. We have the flywheel that actually direct convert the kinetic energy, and also we have the battery system. And I think the latest one is that we are actually designing with the supercapacitor, which actually come with the advantage of fast charging, and I think it's introduced a lot of advantage of that. So in terms of the battery as itself, is actually they come up with a lot of type of the battery that can be in use, and all I think the battery is still in a lot of people are study and highlighting on this kind of the research of the energy management with different kind of battery. And also this actually is not only about the battery storage itself, it's actually related to the energy management system, how the system can be worked to be store the energy. Okay. Or anything that Dr. Mimi can add on regarding the questions?
Currently, I think for our LRT, we are using the supercapacitor bank, but I think it's the same like what you have mentioned.
Yeah. Okay. Yeah. Okay. According to this question, also Ms. Dr. Mimi and also Sim Siyi, I would like to know, for me, because I'm waiting for another question. I would like to know how to avoid if we put side contact, for the third rail and the fourth rail, in ground, according to the animal and also the flood, because if we apply this in Indonesia, I think the flood now cannot be managed, still have a flood. So how to overcome this problem? Dr. Sim Siyi, maybe.
Yes, because actually it's original based on the design. If there is the flood come in a very serious, the very serious flood, no matter you are in the top rail, you are in the slide rail, or you are at the bottom, all will be hit by the flood, right? So actually the design of the top or the side or the bottom is based on the daily, for example, like in the countries that we come with the snow, they're going to have to happen with the, the formation of the ice and all this kind of issue that they can be avoided. So it's actually it come with the flood. no matter the which side they are using, if the flood level is high, all will be gone, all will be under the one. So that is the consideration that when we choosing, so we should choose, is that is suitable that we use for the DC, or the place is suitable if we have to choose with the AC, they come with the overhead. This is on the design matters when we're choosing for the classification of the railway.
Okay.
And I think Dr. Sim, I think in your slide you mentioned about that when we pick up the current for the from using third and fourth, the shoe collector has some protection with it, right?
Yes, that's the thing that we come with the cover, with the protection, with the things. That one, but just how to say, is like a basic cover that we try to protect any exposure of the running rail with the humans or with the animals, or this kind of the thing, that possibility that can happen.
Correct. That covers.
Covers, yeah. Okay. Okay, maybe from another from student, or maybe from the audience, if there's maybe a question.
Dr. Agus?
Yes.
Actually, can we get some time to share about, I think that the topic today is about a little bit on the program and also the FYP, right?
Okay.
Dr. Sim, I'm sorry, I should have give this back to Dr. Sim just now. Dr. Sim, would you like to share the FYP stuff?
Dr. Agus, we still have any time that I can just...
It's okay.
Our originally is supposed to be taught on the program of our railway and also the FYP, right?
Okay. Yeah.
So maybe if we can use this 9 minutes to explain a little bit on the topic a little bit.
Yes. Okay.
All right. So while waiting for others' question in the chat box, maybe we can just answer in the chat box. So I would like to have just a very quick sharing on what is happening in our faculty. Okay, just a minute. I'm going to share my screen. Okay, just a very quick one, not going to take the much time. So we're waiting for the question in the chat box. So actually, this is what happened in our faculty. UTHM actually we have two campus, kita ada dua cawangan, but dua-dua in Johor lah. So bezanya 1 jam daripada satu ni. So kita actually the new campus which is located in Pago. Okay, this is how it looks like. And okay, this is the thing that we like to have the highlight in our faculty is we actually come with a lot of different field. We have electric, we have kimia, we have our mechanical, and we of course we have our railway that we presented just now, right? And also we have our postgraduate as well. All is come in one faculty. So we have 15 programs, 105 MAL, and then we have 4 research centers, and overall we have 158 staff and 2,000 plus students. Okay, this is actually the progress that we have. Okay, for the normal engineering technology program, which is from program 1 to 10, we are all doing in the same way. But for the railway and also the OSH 11 and 12, they will be in another way, which is called it as a WBL. Maybe Dr. Mimi can just log in after this one is the WBL in our faculty. So I would like to show you a short video. This is just a very quick tour of our lab. Okay, never mind. I think it's going to take time. So we just, if there's chance, I'm going to show you after this. Okay. Just a moment. Okay, there's just a very quick view. So we are really hope that in future that we have a cooperation that we maybe can the Unisula can really come to UTH and visit us in Pago, our new campus there. So we can show you all the equipment that we have there. We really hope that we can have a cooperation in future. Okay, now let's go through quickly what is the FYP. So actually, I'm the faculty coordinator for the FYP for our faculty. So yes, we're sharing about the pandemic. So during the heat of the pandemic, it's really for a very hard time actually, and the university come out a lot for rules, a guideline, garis panduan, what we can do, what we can change the scope of this project and so on. So these are the things that come. But it's lucky that all the things just paused for a while and we're now able to process as usual. Okay, so actually in our faculty, we encourage for 4 types of the FYP, which is the practical based, simulation based, statistical data analysis, and also the case study. So, and also the thing that we are actually encourage all our students to have industry engagement. So the target is for the industry to have the knowledge sharing in between both parties. So we are actually encouraging, and also we encourage students go for the patents or copyright engagement and so on. So I'm showing you here that the blue color you can see here is actually the industry, the industry related project. So from all of our department, all kind of program, we are encourage all the students. I think this is what the aim of the faculty of the industry, engineering industry in Unisula happens also. So, and also we have a lot of students that we encourage them to go for all kind of the competitions. Here you can see here we have the best thesis of the students, and then we have a lot of competition here. We got the gold awards in the competition, in the undergraduate research competition. We have the best paper awards. All these are from our FYP students. It's not go for the postgrad students. And we have the winner from the 3-minute thesis 3 minutes. Okay, then we have the best paper awards. And then we also sending the student going for the Malaysia Siswa side is going for the competition, and we win also. There's a winner there. And then I'm showing you more on the electrical projects. This is all kind of the awarding projects that happened here in our faculty here. And then a lot actually just showing a very quick view of the competition. Okay, and now we go for the industry engagement from our FYP students. So we have a lot for we actually have a lot of engagement with the industry that happens because we are nearby to the Melaka and Muar. So you can see here we have a low-cost solid water waste removal that happens in the Pancho in Muar. Okay, and then we have the conducting the research on the Eurofood industry in Negeri Sembilan, and then we have a lot of related to the safety, the noise, and all these things. We actually have another center of the bamboo. Okay, so they are how we can really use all the bamboo for all this kind of thing. Okay, this is just a quick glance, and then these are the industry partner that we have. They really work a lot with our FYP students. We have our My Classic Tank with the topic of wireless monitoring system, and then we work with the Panasonic. They come with the performance analysis of Classic Tank for various liquid material wireless, and then we have the have the automated river water level monitoring system. And then these are the products. After we have been with the industry, we come up with a lot of industry products. Okay, the first thing we have the pusat service kenderaan. There's actually under one in our laboratory here in our makmal, and we have our own pusat service which is under the mechanical department. And then we have our krim penyembuhan luka. They come up with one of our product also from our faculty, from the chemical students. And then we have a lot of the innovative product that actually happens to come up. Yeah. Okay, and this one is some of the industry engagement that we happen to make in our faculty. Okay, now I'm going to show you if you are interested with our project, the report, the thesis in our faculty, or actually it's in our university, you can just simply go for our library website, and then you can find out here there's a UTHM thesis. So inside the UTM thesis, you can just simply search the keywords of your topic, then you maybe can get some ideas on the things that are happening in our university here. You can just get the thesis, have a quick view of the thesis. And also for the publication in our faculty, we have two. One is the proceeding. We call it as the proceeding in engineering application and technology. So we are actually aim for all our FYP students, they're going to publish their paper here, but it's not limited to the FYP student. We are actually welcoming a lot of the other university. So maybe Unisula, the student, after their FYP, they can just proceed to submit the paper with us here. Okay, we are for the we call it as a PR, Progress in Engineering Application and Technology. So it's on the engineering application and the technology, it's not limited to chemical, civil, electrical, mechanical, transportation, and any of the engineering related work. You can just submit here as a part. And also, if the lecturer you are interested to become a reviewer of our team of the reviewer, you can just contact us. Then you can we can be cooperating through with the publication as well. So these are just our many editorial boards and so on. Okay, this is just a quick view on the articles that have been published. So now is actually our second year here. So for the volume, this year, 2021, for the volume 1, we have 100 articles, and the volume 2, we have 105 articles, come up with all different type of the departments here. Okay, this is just a summary of the thing. So actually our first volume is on 2020. It's a very new proceeding come up with our faculty. Okay, this is how the PR looks like. If you go for the website of PR, you can find out this is the technical. On here, mostly is the technical paper for our FYP students. So for our FYP student, it's not going to have a thesis. They need to produce a technical paper. We call it as the paper for submission. So all the paper, the summary of the result, their work, you can just simply get it through here. Okay, just have a quick view. So maybe you can get some ideas, or you can have some knowledge sharing between the publication over here. Okay, another one is we have another Journal of Advanced Industrial Technology and Application, which is really mapped to the industry of the Faculty of the Industrial in Unisura, right? So we call it as a JITA here. It's a journal. So you can just go through with this link. You can just submit, or you can just as a reviewer team. We are welcoming also the as a reviewer as well. Or the student, if you have you feel that the work is good, you can just simply submit here, and we are actually very welcoming for all the publication of our journal here. So this is our JITA. We call it as a JAITA, JITA, Journal of Advanced Industrial Technology and Application here. So we have twice a year the publication. Is a very quick publication what happens here, and this is our editorial board. And it's not limited to electrical, mechanical, civil, chemical, transportation, because our faculty is actually included all the kind of engineering here. So you can just submit any of the work here. We are already welcome for the submission here. This is how the JITA looks like. You can just contact us if you are interested to as an author, or you are just as a reviewer. Again, you can just grab all the paper here. Just for the submission of your paper here, the students, actually for the students submit to PR, if the quality is good and go for the journal level, then we actually proceed the student for the JITA over here. Okay, that's all, just a very quick view from us for the FYP. If Dr. Mimi have anything have to top up with the program of railway.
Actually, I think I just would like to mention that our railway program now is actually having how many, like 20 Indonesian students for the mobility. So perhaps we open for any kind of collaborations, including mobility and also student exchange in the future, if anyone is interested. Yeah, so maybe I share a little bit of our program structure, just a little bit. Okay, this is the program that taking the mobility. Okay, so the program is Bachelor of Engineering Technology in Rail Transportation with honors. Okay, so we open for any mobility or student exchange, but we have to plan. So this program, this railway program, is actually a degree program, which is 3U1I, 3 years in a university and 1 year in the industry. So 3 years students will be in the campus, and 1 year students will be in the industry. So what is the 1 year? The 1 year is like an internship, but it is a structured internship whereby we have syllabus, whereby we have industrial coach that is officially appointed by the university to coach and guide the students. Yeah, and these are some of the students' activities that we have during the pandemic COVID-19. We still have the webinars. Like I said, we also have Indonesian students for the mobility. So if we are interested to have this kind of program, we can just discuss for mobility, for international relation, and etc. Yeah, so these are our students attached to the industry as early as year 1. So this is the year 1 students at the industry. And these are the visits to our rapid rails, like to our operators, and some of the functions, some of the in-house international seminar, industrial talk, mentorship, and etc. So this is the 1 year. This is the 1 year attachment at the end of their program. Yeah, some samples. So our students in their 4th year, they need to be the industry and do work related to railway, like you have that you see now. So these are our students in their 4th year outside. So yeah, that's all. So if anyone interested to study, to have collaborations with us, you are most welcome. We have degree program, we have master's program, we have PhD program, and etc. So I think that's all from me.
Okay, thank you, Dr. Mimi, and also Dr. Simsi. But this one question more, yeah, maybe from Hilma Musyaroh, yeah, from Electrical Engineering 2000. She asking whether the gravel is placed under high voltage equipment to help drain water to prevent accumulation over time. Can the people be replaced with other materials? Maybe Dr. Mimi or Dr. Simsi, yeah?
Yeah.
Okay.
Maybe I can just give a short answer first, or anything Dr. Mimi can top up. So yes, of course we can change with the pebbles with other things, but in terms of the most economic things, the pebbles I think will be the most suitable. And the pebbles is here to come with variety of the pebbles. That is a selection you have to make to choose the right pebbles, because it's not going to have to work under the high voltage for the drainage, helping for the drainage. And also that I mentioned just now, we have to look into the oil leakage from the transformer and other things. So actually, of course, there are other materials, but in terms of the cost, I think pebbles will be the most commonly used. It's not, I don't say that it's the best choice, but it will be the most commonly used in all around the countries there.
Okay, I think that's the answer from Dr. Simsi. Thank you, and Dr. Mimi also. I think because of the time, yeah, already, and thank you very much for Dr. Mimi and also Dr. Simsi. I do hope that all the knowledge that already shared will be give us more knowledge, and also encourage us to study more about especially for the railway electrification, and maybe some of our students interested in study maybe in Malaysia to continue the master, also the doctoral maybe. And for Dr. Mimi, also Dr. Simsi, we also expected that maybe you can sometimes go to Indonesia to see the Inca. We already have old wood steam strain, yeah, since 1867, yeah, from Semarang, from Ambarawa to Bedono. It's along 5 kilometers using steam. Yeah, steam. It's still running, although it's already 120 years old. Yeah, maybe this also a different thing from this session, but still the same trend we do talking about. And thank you for the participants, and give a virtual applause for Dr. Simsi and also Dr. Mimi. And thank you very much. I do hope we will meet soon in another event. And as a moderator, I do apologize if there some mistake from me. Thank you. And then I would like to return the agenda to the Master of Ceremony. Please welcome Miss Indah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
warahmatullahi wabarakatuh. Thank you, Pak Agus, for guiding this session. Very interesting, and also thank you to our great speakers today, Dr. Mimi Vaishali Ramli and Dr. Simsi. So, ladies and gentlemen, let's give big round of applause to our speakers and moderator today. Thank you very much. Okay, what is interesting discussion today? Just like what Pak Agus said, hopefully we can continue the discussion in another time. And ladies and gentlemen, now we would like to present token of appreciation to our speakers today for sharing their expertise to us. And for the first ones is for Dr. Simsi. Thank you, Dr. Simsi.
Thank you so
for
much.
your interesting and informative discussion today. And the second one is for Dr. Mimi Vaishalini Binti Ramli. Thank you, Doctor. Thank you very much. Okay.
Thank you very much.
You're welcome. So, ladies and gentlemen, the whole agenda of the electrical engineering webinar today is coming to the end. Once again, I remind to all participants to kindly fill up the attendance form, and then you may back to the link that you have already registered, and then click certificate to get your certificate for this webinar. And for your information, this webinar series will stand for the next week, and the next week's webinar will be hosted by Informatics Engineering Department. So make sure you have joined and registered to the event. And ladies and gentlemen, once again, I would like to express our great appreciation for all speakers, moderator, committee, and participants. Thank you very much for your participation. I hope this webinar will be very beneficial for all of us. And see you again the next agenda of Faculty of Industrial Technology webinar series. So stay safe, stay healthy, and always be happy. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh. See you again. Bye.
See you.
Waalaikumsalam
warahmatullahi wabarakatuh. Thank you, Dr. Mimi.
Thank you, everyone.
Dr. Sim.
Thank you.
See you.
Thank you, Dr. Sim.